Hey, you guys, this is the last problem over factoring by grouping that we've talked about. It's what if we have this whole big, long quadrinomial and, I've got to factor it by grouping. Obviously I need the two groups with the number on the outside of the parentheses, but I don't have that. Um, and the way you get that is you're going to throw up some parentheses and just pull things out. And here's the thing. I'm just going to guess where to put my parentheses for now. I'm going to put them around these. Um, I might have to rearrange some things and try it. For example, I could do it this way as well. I could do 3ab minus 4 parentheses minus negative b plus 12a. I could do it that way instead. The commutative property allows me to do that. Um, but I'm going to stick with one and try it. And if that doesn't work, I'll try another way. So let's try this first way. When I do this, first things first, you got to look for the greatest common factor. What do these share? And obviously this is only a b, so the only thing it could possibly share is b, and it does in fact share a b. So I'm going to divide that b out. And if you divide 3ab divided by b, well, you're just essentially getting rid of the b. You're canceling it out. And that leaves you with 3a. And then again, b divided by b, you're canceling that out, which leaves you with 1. Now, on the other side, we're going to do the same thing. Hopefully we get a 3a minus 1. Let's see what happens now. When I subtract here, I'll leave that sign here, and notice the only common factor are the numbers, and the greatest common factor that the numbers share is 4. So if I pull out a 4, I end up with 1 plus 3a. And I close off my parentheses. And notice something here. My groups are not the same. I get 1 plus 3a, 1 minus 3a, or 3a minus 1. I need to fix that. And this is a problem that I think has given some of you fits. And really, we're just going to do some good old algebra, some manipulation, all right? I'm going to change the sign. I'm going to cheat. I'm going to change this to a negative b. Now, when I multiply this back out, I better get 3ab. Right now, I would get negative 3ab if I multiplied it back out, and that doesn't work, but I can counteract that simply by putting a negative sign here. And now negative b times negative 3a would still give me positive 3ab. Same thing over here. Negative b times negative 1 would give me a positive b, and I had a negative b in the first place. But if I change that to a plus sign, now I'll get that negative b again. So this works. This right here is exactly the same thing as this. So we're all good. But now notice 1 plus negative 3a is the same thing as 1 plus 3a. Or if I really am paying attention, these are not the same still, are they? And pulling out a negative here isn't going to change that, unfortunately. If I've already tried it on one side, it's not going to work on the other. So right here, I found my answer. The answer is this is prime. I've factored it as much as I can possibly factor it, and no more. Now you might be thinking, well, what about trying it a different way? What if you rearranged it? That's a good point. So I can try that if I want, but I might not get the same result. So we'll see. Let's try it a different way. If it doesn't work a different way, we'll know it's prime for sure. Remember earlier when we rearranged it? This time let's put, I don't know, the a's together. So I'm going to write it as 3ab plus 12a. Remember, you have to keep the sign that's in front. And then that would be minus b minus 4. And now I'm going to add back in parentheses. Notice this is already factored, so I'm just going to leave a 1 on the outside there. If I factor this, I can pull out a 3a, and I get, ooh, this is looking tantalizing. I get b plus 4 minus 1 times b minus 4. I think our negative trick might actually work this time. How do I know? I understand what this and this really mean, but let's just check here. I'm going to go ahead and make that a negative. If I make that a negative, this must also be a negative. And likewise, this must also be a negative. And it's still not right, is it? That's too bad. Um, well, we're still not at total loss. We have another combination that we could try. So let's go all the way back out. See if we can try it one more time. The only thing we haven't done yet is to group the 3ab minus 4 and then minus b plus 12a. Unfortunately, it looks like when I group it this way, there isn't really any common factor I can pull out. So unfortunately, I think I can say beyond reasonable doubt that this is prime. I tried it all three ways. I rearranged it, and I still couldn't get the factors to pull out to make this work. So unfortunately, that happens sometimes, and it's sort of long. You know, it took me 6 minutes just to get all the way through this and figure out that it was prime. But really, if you understand what you're doing, you can go quickly and really move through it. If you have any questions on this, feel free to hit me up. Good luck on this.